All right. Good evening, everyone. Thanks for being here. My name is Kaushik, and I'm an Android developer. I'm going to be talking today about RX, or reactive extensions. Many people feel that RX, or reactive extensions, has an extremely steep learning curve, and it definitely does have a steep learning curve. But as my friend Dan put it, RX is a complex solution to an even more complex problem. And what I found when I was trying to learn RX, that the best way to sort of grasp the concepts of RX or reactive extensions is essentially if you just take certain common real-world examples and you try to solve those examples using RX. So that's basically how I've learned all of my RX. I've just basically taken common real-world examples and I've tried to apply RX on top of them. And today, what I'd like to do is to share that process with you. So if you want to see the agenda for today is to first just give you a 2-minute brief introduction into what RX is. This is for the kind people who wandered into the room, and if you've somehow gotten into the wrong room and you don't know what RX is, well, in that case, well, you at least should know what reactive extensions is so you can hold on till the end of the session. But other than that, what I would rather do, this is meant to be a slightly advanced session. So what I'm going to do is I'm going to jump in and take 3 relatively marginally complex examples. I wouldn't say they're very simple. I wouldn't say they're extremely advanced. But these are not contrived examples. These are real examples that I've needed to solve in my day job as an Android developer. And I found that using RX for these examples made it extremely easy. And I was able to arrive at an elegant solution. And so I want to jump in and talk about these examples, which is what I think like the juicy part of all this is. So let's quickly jump into the introduction for what RX is. I think the best definition of RX comes from the main repository itself. RX is basically an API for asynchronous programming. So if you're a JavaScript developer and you've dealt with futures, promises, callback, the callback hell and all that stuff, then RxJS is perfect as a solution for you. If you're an Android developer and say you want to execute a network request on a background thread, then you want to transform that data on yet another background thread, and then finally you want to present that output into a main thread, then RxJava is perfect as a solution for you. And if you're an iOS developer, I mean, I don't know anything about iOS development, but I imagine Rx Swift is an equivalent, and at least that's what many of my colleagues tell me. Rx Swift is something that achieves the same objectives. So the advantage with Rx is it's available in a wide variety of languages, which basically means then it's available in a wide variety of platforms. And so the beauty is, because it's just simply an API, if you learn these concepts, they translate across different platforms. So if you learn it in one platform, I've primarily learned it in RxJava for Android development, and I've found that when I do a little web or front-end development, I can actually very easily drop into RxJS. So that is the advantage. How is the API of Rx actually implemented? It's all about the observer pattern. So they heavily use the observer pattern, and the tagline from the repository itself is, it's the observer pattern done right. But it's actually a little more. It takes the best ideas from the observer pattern, from the iterator pattern, and also functional programming. So initially when it started out, many folks felt that RxJava was a sort of functional reactive programming API or library. This is not, I mean, there are many people who feel strongly that this isn't an accurate definition, but for all practical purposes, it uses like the functional paradigm pretty heavily. So what does a typical Rx call look like? So this is RxJava. I'll be using RxJava for the rest of this talk. A typical Rx call basically starts off by creating an observable right at the top, right? So this is how the basic anatomy of an Rx call works like. You start off by creating the observable, which is like your source of data. Then what you want to do is you want to transform that data. And this is where the beauty, and this is where all the magic in Rx lies. You can essentially use operators to keep chaining different methods, and you can transform data in a crazy number of cool ways. In these examples that we walk through, you'll see like you can, with the call of just a single method, you can do like things that would otherwise be like extremely complex to achieve. So that's the second part where you actually transform the data. And right at the very end, what happens is once you have this output or this data transformed, you want to be able to, you add a subscriber to this because it's an observer pattern. You have the observable, which sends the data from top. You eventually want someone to listen to this and actually do something with the data, right? So that's where you attach a subscriber to this. So this is basically the call. There's also some things where you can specify these things called schedulers, which are essentially upstream or downstream. You can say, hey, hop onto this background thread, move to this thread. There are talks that are given just purely about these things, so I'm not going to go into the details, but these are like a nice side thing to know with Rx. So just a quick recap, right up top, we have the observable that creates the source of the data. You apply transformations on that data, and right at the very bottom, you have a subscriber that listens in and does something with this data. All right, so let's jump into our very first example. The first example, so let me explain what I'm trying to achieve with this example. I have a mobile phone, and I have two sources of data. So I have this database that's on my phone. So it's a local database, typically like SQLite or something. And I have results that come in to this database, right? Now, the nature of the results that come down are that they're very quick. Because it's a local database on your phone, these things are snappy, right? Like the results come in right away. But the only problem with having the results purely in the local database is that they tend to be stale, right? Like, for example, if you have a backend server, as is typical for most people who like develop mobile applications, the most fresh form of data, or the newest form of data, is available in a backend server. So typically what you also want to do is execute a network request and have that network request. Typically network requests take a longer time, but once they complete, you want to take those results and swap it out with the local database results that you have, right? Now you would say, why are you going through all of this? Well, it helps with a very snappy app experience. So if you open your mobile phone and immediately you see results from your local database, and as the network request happens in the background and you swap the results, it just has a very nice app experience. And so if you really want to do this in RxJava, how do you do it? Well, they have this saying, there's an app for anything. In Rx, there's an operator for almost anything, right? So there's this operator called merge. And so the way this is how it looks like in code. It's very simple. It's observable.merge. And then you provide the two data sources, right? So in this case, I have a disk results observable. And this is typically what gives me the results from my local database. And I merge it with another observable, which pulls the results from like a backend server or like the network request, right? I should point out that both of the merge operator basically takes in observables as arguments. So I've written, for the purposes of brevity, I've just written this as get disk results and get network results. But the return type for these are essentially observables themselves. All right, so you may think everything is fine, and for the most part, everything would be fine. There's just one small problem with the merge operator. You see, if you basically have results that come down, the local database pulls these results faster, and things typically work this way, so all's good. But for example, for some strange reason, we live in the world of software, strange things happen all the time. For some strange reason, if it so happens that your network result happens to be a little faster than your database result, and this can totally happen, the merge operator isn't going to actually understand the result age, right? All it's going to do is like, hey, this is the result I got. You deal with it, right? So it's going to send the result down. And what would typically happen is like the database result might override the network result. And this is typically not what you want, because essentially what's going to happen is stale data is going to update the fresh data. So how do you typically handle this with the merge operator? For the longest time, what I did was, you know how we talked about the anatomy of an Rx call? You had the observable right at top. At the point of subscribing to this call, what I did is I added logic to basically check to see where the results were coming from. So if I've already shown a result in my list, all I did is I would see in that result if this result came from if my list view already has a result, and it so happens that the result that's coming down is from the database, then I just ignore this result, right? Because, well, if I have the results from the network, then, I mean, I don't really care about the database results anymore. So I did this, and obviously if the results come from the network, then I add it to the list, as you can see in the bottom, and then I refresh this list. This worked for a very long time, and I actually did this for the most part. But then as I was sleeping one day, I had this vision of like this Jedi Knight that came to me, and essentially, well, I mean, it wasn't a vision. Essentially, this person called Jake Wharton sent me a tweet saying, hey, there's actually a much better way of doing this. There's a more RX-y way of doing this. And what he sent me was a code snippet. And Essentially, it's this code snippet. Now, if you look at this code snippet, and this is very typical of RX, it's very daunting to begin with. When you look at this, I was like, what? This makes no sense, because like there's operators flying all around, and then like you have no idea what's happening. But this is actually a very elegant and it's actually a very beautiful solution. And what I'd like to do now is to break this problem down and show you how we can build a solution up. This is very typical for all the examples that we're going to see today. You start off with the smallest problem set. You try to develop the solution for Rx in it, and then you keep building it up to form this huge problem set, right? So essentially, that's what I want to do with this. Let's try to break this problem down into the smallest set. What's my problem with the merge operator? Well, it so happens that when the database sends results down, well, that's fine. But the minute I have my network observable also sending down results, essentially what I want is I want the database to stop emitting data, right? So let's try to just solve that mini problem set to begin with. Rx has this operator called take until, and this works beautiful. So what you do is you say get disk results, take until, and as an argument, you pass the observable that has to act as a gate to when the disk results stop. So I provide this argument saying network results. Now you have to remember, this network results, all it does is it acts like a flag. It basically acts like a gate saying, hey, you get the disk results, but the minute this person starts emitting, just halt, right? So this code snippet that I have achieves that problem set. I have this code snippet that basically says, okay, you start with the database results and you stop as soon as the network results start, right? But that isn't necessarily enough, so we're going to move one step above this. You have the disk results, but at some point I also need the network results, right? This code snippet at the bottom that I have only gives me the database results. So we looked at the merge operator to begin with. So what happens if you just merge this code snippet that I have with the network observable, right? It actually works perfectly well, because if you think about it, say, what was our problem before? If it so happens that the network result observable starts at a later point and the disk results might override this, that doesn't happen here because you're not going to get any disk results the minute your network observable starts emitting, right? So for the most part, when you merge, conceptually, you're done. This is exactly what we want. But unfortunately, as it is the case with software programming, it's a little complicated than this, because you see, this get network results. Let me swap this code snippet out with with the actual code snippet here, right? You see, this get network results is actually immutable. In the case of, in the land of observables, everything is immutable. So this functions as an independent instance. So if you call get network results there, and you also call get network results in the nested call, they function as two independent observables. And so there is a chance of a race condition happening, right? So how do you account for this? How do you solve this problem? Well, if I could share that observable somehow, then that would actually solve my problem, right? The minute you think about sharing, whenever you talk about Rx Java and you have Rx in general and you want to share things, then there's this operator called publish that you should talk about. And publish is like this amazing operator, because the way it works is, let's actually look at it in code, right? Publish needs to be called on a particular observable. So what observable would I pick in this case? Well, what is the observable that you need to share? It's the network observable, right? So I would call the get network observable. Let's swap it out here. I have the get network observable, and I call publish on this. Now the beauty with the publish function is that it gives you an argument, and this argument is an observable itself, right? So in this case, this network that I've named as a variable is actually a network observable, and it gives you a guarantee that at any point in this function, if you use that network observable, it will be shared. It is the exact same instance, right? So now all I have to do is wherever I call get network results, I can just swap it with network here, and I can swap it with network there. And if you actually look at this code now, it's actually the exact same thing that this other developer, Jake Wharton, sent me, right? So if you see, when we walked through this step by step, it actually didn't look, it wasn't that complicated if you broke it down to the smallest problem sets, right? And this is exactly the code snippet. The beauty with this code snippet versus the one that I originally showed you is that all this hacky sort of way of handling the result set, where checking if the list contains the result, does it come from the network, does it come from the database, you don't have to worry about any of that, because this code snippet automatically takes care of that by virtue of the way this chain is processed, right? So that's the first example, and the publish operator is really the takeaway from here. This is like a really cool operator, so when you get time, you should have a look at how it works. Let's jump into our next example. I want to use this concept called subjects in Rx Java. So what are subjects? That when I looked at the definition of subjects first in Rx Java, it made no sense to me because it basically says a subject is essentially an observable that also acts as a subscriber. And I was like, what? That doesn't make any sense because it's essentially the polar opposite of both of these things, right? When would you ever need something that produces events that also listens to events? Well, after I had to implement this example, I understood exactly why you would need a subject. So I'd like to walk you through this example. In the Rx community, subjects kind of get a bad rep. They get a bad reputation, and this is mostly for different reasons. But I honestly feel they're extremely powerful. But if you use it in the right way, there are like some crazy use cases that they make very easy to achieve. So if you have time and if you have questions, I can tell you why some of these things are thought about, like why people don't like subjects. But I really wanted to use subjects in an example because I want to show you what you can really do with subjects, right? Okay, so this is essentially a demo app that I wrote. And I have this example of a paginator, right? So like I have pagination happening in this list view. It's a basic list view, and essentially what I do is as I scroll to the end of the list, I want to pull in more results. Like this can come from anywhere, it doesn't matter. For this example, you can maybe execute a network request, say, hey, get me page number 1, it gives you the results, right? I scroll more as I reach to the end of the list. I say, okay, I'm done with page number 1, give me page number 2. It gives you the next set of results, and so on, right? So you can keep sending page numbers. So this is essentially what I want to achieve with this example. Let's see how we can actually do that. The common theme, as always, is let's try to build the simplest example. Let's look at the smallest problem set and then take that and build on top of that problem, right? So what I want to do now is forget the whole pagination thing. If you had just one page and you had the list of results for just a single page, how would that work? Let's try to build the example first to solve for that problem, and then we can swap it out and sort of add the whole pagination function on that. So there's this really useful operator called just in Rx, and essentially what it does is it takes a single value type, so a primitive value. In this case, I've used the primitive value 1 because that represents the first page, so page number 1. And it converts it into an observable, right? So this is a very basic way of creating the source of an observable. I've created this source of this, I've created this observable source. Then I apply this operator, which you will see extremely often in the land of Rx, and even in many like functional sort of like programming languages. It's called flat map. I want to quickly bring in this cheat sheet that I keep convenient in the back of my mind. I call it the holy trinity of Rx conversion, because essentially whenever you want to transform one object type to another object type, there are like multiple combinations. You would maybe want to take a single object type, transform it to another object type. You might want a single object type and transform it to an observable of another type, which is actually what we want in this case. And the flat map operator essentially does just that. It takes a single object type and it transforms it into an observable of another type, right? So I'm going to use the flat map operator here because what I want really is to take a single page number, which is like this integer value. So it's like an object type, it's a basic object type, and I want to transform it into an observable that gives me the list of results having hit this network result or wherever you're getting your results from, right? So I use the flat map operator here, and if you see, the argument is the page number, and this method, I mean, obviously it's pseudocode here, like it doesn't really matter for the purposes of explaining this example, but essentially the method that I have ready here is I might hit a network observable, I might do something else. I would provide the page number and I expect a return type of an observable, right, of a list of items. So this is what that get network results method looks like. I've used flat map, and again, I have my first page of results. So what I want to do now is I want to add a subscriber to this that understands what I do with the list of results, right? So this is very basic boilerplate code for what a subscriber looks like. And right at the very end, I get access to the list of items that come down. And essentially what I do is I just add it to the list, right? So with this, essentially what I've done is I've taken the first page and I've presented a list of results and I've added that to the list view. There's one small modification I want to do with flat map. The problem, there's this other operator called concat map, right? So concat map essentially is the same as flat map, but the concat stands for concatenate. Think about this problem. Say I have this this pagination happening, right? But for some reason I go crazy and I keep scrolling the list really fast. You might say, hey, get page number 1, get page number 2, get page number 3, get page number 4. And it might so happen that this source that's sending you the results takes a little longer for one of them. So like page number 2 might take a little longer than page number 3, right? So what's going to happen with flat map? Flat map has no idea of order, right? So it's saying, hey, I got these results, do something with this, right? So it's very similar to the merge operator in that like whatever results it gets down, it's going to send that down the pipe. So, but what concat map does, it's exactly the same as flat map, but it respects order. So if you say, hey, get me page number 2, get me page number 3, get me page number 4, if it so happens that page number 3's results have come down faster than page number 2, it actually waits. It buffers the results until the request that actually was executed is fulfilled. So that's just a small variant of this flat map called concat map, right? Okay, so where are we at this point? We have gotten the first page ready, right? And we have the list of results. We did this for page number 1. Now, if you think about it, what if I could just instruct the observable to say, hey, also get me page number 2, right? I've done it for page number 1. When I created the observable, I said, get page number 1. If there was some way right at the very top that I could say, just also get me page number 2, also get me page number 3, right? What you're basically asking at this point, so like you have created this observable and you have the page numbers coming in from the top. What you're essentially asking now is like, hey, I have this observable that's emitting events, but also, can you act as a subscriber temporarily and listen to these other events that I'm sending you? So this is exactly what a subject is, right? So if you see, this is an observable that sends a list of results anyway down, but it also temporarily listens to a couple of other events from these other places. So this is exactly what a subject is. And if you see in terms of code, let's look at the code now. It's like ridiculously simple to actually implement a subject. Now instead of this, let's first create a subject. And the way I do that in code is basically I create this thing called a publish subject. Now there are a whole bunch of different subjects. There's replay subject, there's behavior subject, there's async subject, there's publish subject. You don't have to worry about all that for now. Just know that the publish subject is the simplest form of a subject. Essentially what it does is give me this event and pipe this event down. It acts literally as a pipe. There are certain other subjects that do like some pretty funky and cool stuff. There's like the replay subject, which essentially says all the events that come down, I'll remember these events and I'll start replaying them to whoever asks me again, right? Just a side note, for this case, let's just use a publish subject because that's more than enough for our use case. I've created this publish subject and it acts very much like an observable. So what I could do is I could just knock off this place where I say observable.just1 and I could substitute it with this subject, which I call paginator out here. And 90%, you're done. Like 90% of this example is already complete. But the only problem now is, well, okay, so where do the inputs come from, right? Like my page numbers are missing. That essentially what I do is, again, because this was an Android application, I don't want to go into the specifics of how I implemented it specifically. All I do is I know with my implementation of my list, I know when I'm reaching the end of the list. So when I reach the end of the list, all I do is I say, okay, hey, paginator, take this next page number, right? So on next is an operator that I can call on the paginator, and I can essentially just keep sending down page numbers to this. So when you reach the end of the list, I could say, hey, I need page number 2 now. You send the page number 2. When those results come down and those are displayed, you can again say, okay, it's time to get page number 3. So it's very easy. If you think about it, it's like this pipe, right? Subjects act like this pipe where you can send an event from one end, and then the list of results, or like from the other end, you get the list of results, right? So subjects are extremely powerful, and this is the example. So typically, if you have to implement pagination, it's pretty tricky if you think about it. But when you use Rx like this, it's actually very simple because you've forced the stream of events flowing in a specific direction, right? So this is example number 2, and with this we go to the final example. So if you thought those examples were slightly complex, this one goes all crazy. The company that I work for, Instacart, essentially open sourced a library recently called TrueTime, right? So what is TrueTime? It's there's these servers called NTP servers, right? So TrueTime is an NTP library that helps you tell what the current time is now. Now you may give me a crazy face and say, like, why would you ever need this? Well, if you pull up your mobile phones and you actually go to the system settings and change the date and time, it'll actually respect those settings. So if you work in a business application and you need the current time now, not the time that's been affected by the users in any way, it isn't very easy to do that on a mobile phone. So the established solution, this is a known thing, this isn't anything new. The NTP library essentially acts like this server, and all you do is like you tell the NTP server, hey, give me the time now, and it gives you the time now. So it's actually a very simple concept. Unfortunately, the NTP spec is this thing that's like developed like 20 years back or even longer, and it's extremely abstruse and it's really complicated. So I'm not even going to try to explain it in words. I want to show you a visual diagram of what's involved in actually doing this NTP request. The way it starts off is you first hit this thing called an NTP pool server, right? So an example of an NTP pool server is like time.apple.com. Apple has this NTP server where they, out of the generosity of their hearts, they allow everyone to hit the server so they can hit time. Amazon has this, like there are a whole bunch of these common NTP pool servers that are a collection of server boxes where their only responsibility is to tell you what the current time is now, right? So pretty convenient job there. But what the first step that you actually have to do when you want to hit NTP is actually pick specific server boxes, right? So you do this with basic DNS resolution. So time.apple.com is like a DNS common address, but what you have to do is you have to pick specific server boxes in this pool, right? So you do, the first step is actually a basic DNS resolution. You would hopefully expect to get potentially 4 IP addresses where each IP address points to a specific server box. And this is where we start to get really crazy, right? What the NTP spec tells us is against each server box, you're expected to send 5 network requests, right? I keep calling these network requests. They're actually not network requests. They're these requests called SNTP requests, right? If you think about typical network requests, they're HTTP. One of the advantages of HTTP requests is they're extremely stable, right? They're known to be reliable. SNTP requests, however, run on this protocol called the UDP protocol. UDP requests are extremely fast, and so for the purposes of getting the time, it's perfect, right? The problem with UDP requests is they fail all the time, right? They're extremely flaky. And so one thing that you have to account for when you actually send these independent server requests is things are going to fail. So the NTP request and the NTP spec says, hey, these things might fail, so it's up to you to make sure that you retry until you actually get a successful response for every single SNTP request, right? So this is basically the first step. Assuming you get responses from each of these, you want to collect these and you want to filter the responses that come from this request. You do it with this attribute called round trip delay. Don't worry about what round trip delay is. It's just think of it as an attribute that's tagged onto your response, right? So you're collecting all these responses and you want to filter these responses based on round trip delay. Now remember, this is only happening on one server box, right? You have this happening in parallel with 4 server boxes. You filter the response, you get each response. You get one response from each of these server boxes. And then you want to do the same process where you actually collect these responses, you sort them by this other attribute called clock offset, and then you pick the median response for this. Now, this looks really heavy. And if you think about actually doing this without a library like RX, it's actually miserable. It's like a nightmare. When I saw this, I was like, I have no idea how I'm going to implement this, right? But RX actually makes this relatively easy. The final step obviously is like from the response that you get, you finally convert it to a date object. So when I said, hey, server, give me the time now, it isn't as simple as just giving you a single response. Like you have to do all this crazy hoopla and dance to actually get the final time. So what I want to do now is I want to quickly run through how I would build this using RX, right? Again, I'm warning you in advance, this is a pretty heavy example. Don't worry if you walk off to the session and you can't remember how to actually implement this thing from memory in an IDE, don't worry about it. All I want to show you is like the variety of operators that you can actually plug in and how easy it is to use RX to sort of handle some of these edge cases that I mentioned. All right. Now this library is open source. You can actually look at the code here. All that craziness that I talk about in what's needed to resolve the NTP and perform the full implementation of the NTP is contained within this code snippet, right? And it's actually it looks pretty good. It reads pretty well too, right? But all you have to care about now is that same paradigm that I've been trying to hit. Look at the smallest problem set and try to build this problem one on top of the other. So let's try to actually do that quickly here, right? What was the first step that I said? Okay, you have this NTP pool server. For the purposes of illustration, let's just take time.apple.com. The first step is DNS resolution, right? So I want to resolve these things into 4 independent IP addresses. What does this look like in code? We looked at the just operator, so that NTP pool address would basically be time.apple.com, right? So I've taken this object and I've converted it into an observable, right? So that emits a single value. Now, you remember I showed you that cheat sheet about like the holy trinity of conversion? Like one of those things was actually the compose operator. Whenever you want to transform an observable of one type to an observable of another type, the flat map operator, if you remember, was transforming a single object into an observable, right? If you want to transform a complete observable into another observable, you use this operator called compose, right? So this is another operator that's available with Rx. This is what the actual method looks like. It has very aptly an argument called transform, which basically transforms one observable to another. I want to quickly call out this inet address.getAllByName is essentially just an Android utility method that does DNS resolution for you. So you just provide it with an NTP pool address, and what it does is it executes whatever it does for DNS resolution, and it provides you with a Java list object, and this Java list object contains the IP addresses for that DNS pool, right? But what I want to do is I expect the response to come in the form of an observable, not really a list, right? That's why I have this from operator. So I say observable.from, and what this operator does is it takes a list object and that converts the results of those into an observable. So it gives you an observable that emits those events one after the other, right? So that's this code snippet that takes care of like the first part where I got a DNS pool address and I've resolved them into single IP addresses, right? So now what we're doing is we're entering this single server box. So let's try to focus on the action that's happening per server box, right? What was the objective? So the objective is I need to execute 5 independent parallel network requests against a single box, right? So how would I do that? Let's first try to look at what my objective is. The objective is I have this single object, which in this case would be the IP address of server box 1, and I want to transform that into an observable of response type, right? Don't worry about what that response is. This is an SNTP response. It's essentially, if you look at the code, it's essentially the Java type long. It sends you like a bunch of longs and you're supposed to like resolve those things, right? Don't worry about all that. All we want to care about is like the Rx part of this example. So if you remember the cheat sheet that I mentioned, flatmap was the thing that would, again, allow you to transform an object into an observable, right? So that's why we're going to actually use a flatmap operator here. Let's look at the actual method. This is, again, where we get into some of the really cool operators, right? I have the single IP address inside this method where I call just on. So I've gotten an observable. And this is the power of Rx, right? So what I'm doing is I'm just saying repeat, which is an operator, and I specify the number of times. What this does is it basically says, hey, whatever the stream of events that I just received, I will blindly send those events again to you as though they were being repeated, right? So it's as the name suggests, it's just like repeat 5. So in this case, it's going to repeat the last event 5 times. So if you see what happens here, what's going to happen is that IP address, the single server IP address, IP1, is going to be emitted 5 times to you, right? So that's basically what I've done. Well, that's not enough. What I need is to actually execute a network request on top of those things, right? But the way I've sort of structured the implementation is the onus is on me. I have an IP address that's available to me. I want to convert this into an SNTP response, right? And so what I do is essentially I execute a network request, and that's this SNTP network request method that I have. Don't worry about the implementation. All that does is it takes in an input of an object and it converts it into an observable. Now, I said I have an object of type IP address, right? And I want to convert it into a response. I could have used a map operator. But the reason I've chosen to use a flat map operator is because, again, if you look at the cheat sheet, it converts it into an observable, right, the response. And I intentionally want this because of this other thing that I mentioned to you before about it being a UDP protocol. The problem with it being a UDP protocol is it's going to fail. And again, this is like with a single line called retry, what Rx does is it actually waits to see the response. And if it encounters an exception or if it encounters basically an error, it understands that that request alone has to be retried. Now we used repeat. I want to call out the difference. Repeat is just blindly, whatever you give me, I'm just going to keep repeating this thing, right? What retry does is it basically looks at the response. If it's an error, only then does it repeat the request, right? Just think about this. If you had to do this with regular callbacks, this would be a complete disaster, right? I cannot even fathom how you would actually do this with callbacks. Like imagine the amount of state that you have to maintain. This, all Rx does here is basically you just slap on a retry operator and it knows that it needs to retry this. And if you remember, this is happening in four server boxes parallelly, right? This is like one branch that we're focusing on, but with Rx, because we think of all of this as just a stream, it applies across multiple server boxes. So this is, and I promise you, this is where like all of the example, they're coming to the end of this example because I know it's getting pretty heavy. What we're going to do now is basically we're going to close this operator and we're going to walk into this filter process that I talked about, right? I have an observable of response that SNTP request has given me. And what I want to do now is actually I want to collect these and form a list. So I want to do the reverse of that from operator that I told you. Why do I want to do this? Well, it so happens that in Java, sorting a list is really, really easy. So the NTP spec basically says I need to sort this by this attribute called a round trip delay, right? I need to sort the responses with the least round trip delay. And the way I do that is because toList gives me a list object, I'm going to use the map operator, right? So this might seem a little confusing, but basically, if you think about it in terms of Java, I'm actually just converting one object into another object. It so happens that this list object that I have contains multiple responses. But really what I want is to pick the right response from that list and then convert that into the final object type, right? Which is why I actually use a map in this example. I use collections.sort. This is all like very regular Java stuff, so I mean don't worry too much about it. I provided a comparator, and in this case, the comparator understands the logic for the round trip delay, and I send the very first response. So with this, basically what I've done is I've filtered out of all of these responses, I've picked one response. So let's step back and see where we are in all of this NTP spec implementation, right? I was focusing on the action that was happening just in one server box. Now what I want to do is actually a very similar process, and so I'm going to run through this very quickly, but the only difference between the code that I'm going to show you now is that now we are applying the same toList process across multiple server boxes. So if you look at the final code, it's actually very straightforward. So I do the same thing that I did last time. I have a toList, and then I do a map operator because I want to convert it into a list object. And this list object, essentially, again, I call collections.sort on that, and I pick, in this case, the NTP spec says you don't pick the first response, you basically pick the median response, right? So, I mean, I've just gotten a little lazy. I've not been very mathematically accurate here, but I just took like the middle response and I called it the median response. And I returned this response finally up top with the code. So if you see, finally, the response that I get back, I convert it to a date object because the consumers of the library obviously in the end want a date object, right? So if you see, this is essentially how I built the solution up in Rx. It seems pretty daunting at first, and honestly, the takeaway from this is don't worry, like if there's anything that you can take away from this talk, it's that if you encounter some of these examples where like, hey, I've run into this process where I need to just do something multiple number of times, then you have the repeat operator, right? If you have this use case where you've run into an exception and you want to retry only that exception, then you know the retry operator exists. There's a from operator. There's a whole bunch of these operators. So I do hope that eventually, if you run into some of these complex examples, you choose Rx as a mechanism of like handling this, because trust me, Rx is extremely powerful and you can do like a whole bunch of crazy things with this. So this is essentially the end of the final example. You're welcome to, we do have a couple of minutes. We have like 2 to 3 minutes. So if you have any questions that you want to ask me, now would be a really good time to do that. Or that's my Twitter handle. You're welcome to always see some of these links and hit me up if you have any questions. Do you folks have any questions? Please. With subjects. Yeah, okay. So the question was basically, when I talked in this presentation, I said subjects get a bad reputation in the RX community, and like the question is, why do they get a bad rep? So it starts off with this. So if you think about functional reactive programming, right? Essentially, reactive programming is when you have a source stream, you only want to react to it, right? You don't necessarily want to do what are called side effects. So in functional programming, side effect is when you're trying to mess with this stream. You're trying to deal with state in an external fashion, right? So what subjects really are doing is you are messing with state, right? So if you think about our pagination example, strictly speaking, I should have only gotten the first set of page of results, right? But what I'm doing is like I'm meddling with that subject, I'm meddling with that stream saying, hey, also do it for page number 2, also do it for page number 3, right? So they essentially call this side effects, and subjects basically make it really, really easy to mess with your stream and perform side effects. So that's why typically people, it's an extremely powerful concept, and so what happens is if you're not very familiar with the implications of performing a lot of side effects, people tend to go gung-ho and start using subjects a lot, which is why people are like, hey, like hold on, don't go too crazy with subjects. So that's why they essentially get a bad reputation. And strictly speaking, it is possible to actually rewrite that example using pure observables, but subjects just make it so much more simpler.